Welcome to week 3, lesson B, Introduction to Radians. A lot of y'all have experienced radians before by taking your calculator out of radian mode and putting it into degree mode. So hopefully today you can kind of understand what radians are and how they differ from degrees. So let's just first talk about the definition. A radian. A radian is an angle where the arc length is the same measure as the radius. And I'm going to show you an illustration here in a bit of what that actually looks like. But like on the unit circle, we have always a radius of 1. So if I'm looking for an arc length where it is exactly 1, that's the angle that I'm going to be kind of looking at. So it's a different way of looking at like points on a circle or an angle measure. Essentially, radians are just numbers. So they're unitless. Degrees have a degree symbol, feet have feet, percentages have the percent sign. Radians are just numbers. So like I said, if we were to see how long one is on the arc length of a circle, that's all that is. You can say it's 1 rad, but really I'm just graphing what 1 looks like on the edge of my circle. So if I'm talking about this circle and I'm talking about arc length, there's another word for arc length that we have. It's called circumference. The circumference of a circle is given by the formula 2 pi r. Remember, not pi r squared, that's area. That's something that a lot of people kind of mix up. But circumference, that's pretty much just like an arc length of the whole circle. So let's figure out what the arc length of a whole circle is. Well, again, we're talking about a unit circle, so the radius is really going to be 1. So that means the circumference of my circle is going to be 2 pi. So kind of like degrees, we started off on that positive x-axis and we said that was 0 degrees. Well, again, since radians are unitless, I'm just going to say that we're going to start off at 0. All right, well, that means that if I go a full circle, the arc length is going to be 2 pi. So from beginning to end is 2 pi, like from beginning to end in degrees is 0 degrees to 360 degrees. So what about all these quadrantal angles? Remember the angles that are on the axis. Well, the easier one to think about first is, well, what's half of a circle? 180 degrees. Well, in radians, half of 2 pi is pi. So that means 180 degrees is going to be the same thing as pi. It's going to be one's in radians and one's in degrees. Well, if 180 degrees is pi, then half of that is pi over 2. And then the last quadrantal angle that we have that's on the axes is going to be 3 pi over 2. So this is kind of our new like 0, 90, 180, 270, 360. It's 0, pi over 2, pi, 3 pi over 2, and 2 pi. When referring to the unit circle, our radians will always be in terms of pi. But at any time, radians, again, are just numbers, and those numbers can be without pi. So like I can ask you to, sketch what 2 looks like in radians, and you're going to be able to do that. It's not going to be in terms of pi. It's going to be different than 2 pi, but it's still, we're talking about what radians are. So I have a kind of cool video here that I found. So let's kind of see the illustration of what a radian is. So here we have a radius and a circle. That radius has a certain length. And again, on our unit circle, we usually say that that's 1. So what if we take that radius length and we put it on the circle? Well, that is essentially what 1 radian looks like. It's the arc length is the exact same length as the radius of our circle. So for, in the unit circle, we have a radius of 1. So this is what 1 would look like on, a circle. That angle measure, that green one that's in there, that's kind of close to 57.3 degrees. So if I ask you to graph 57.3 degrees or ask you to graph 1 radian, it's going to look kind of exactly the same. Now, what happens if I extend this? What if I ask you to graph 2? Well, that means I'm going to graph 2 radians. So from the beginning to the end, it'll look kind of like that big arc. Well, what about 3? Well, 3 would look like this. And then, pi being 3.14 kind of goes to that half of that circle. So half of our circle is pi. And then again, we talked about how the circumference of a unit circle, is really just 2 pi. So that's kind of a quick illustration of what radians look like on our kind of unit circle. So let's go to our notes. All right, so let's look at some examples. So over here on my paper, I already had this drawn out, but this is essentially what 1 radian looks like. So again, if I ask you to graph 1 in radians, this is what it looks like, which again is approximately 57.3 degrees, which I'll explain later how I got that. So again, radians are just numbers. So what I used to have on my quadrantals used to be 0 degrees, 90 degrees, 180, 270, 360 degrees. Well, in radians, I can again put these in terms of pi, or I can put these in terms of numbers. So like, for example, in my video that I just showed y'all, this was pi over 2. Well, pi being 3.141592 and so on and so forth, if I divide that by 2, that's approximately 1.57. So I could say, anywhere close to this, I could say I can ask you to graph 1.5, and it's going to be very close to that positive y-axis. Well, over here was pi, and I'm just going to approximate it as 3.14. And down here, we said it was 3 pi over 2, which is close to 4.71, and 2 pi being 6.28. So again, radians are just numbers. So if I asked you to graph, 2 in radians, well, that would be over here. If I asked you to graph 5 in radians, what quadrant would that be in? Well, that would be over here in quadrant 4, because that's going to be somewhere between 4.7 and 6.2. So that's always going to be good to know. And again, the way I did that is up here was pi over 2. So I just put in the calculator, pi divided by 2, and got this decimal. Down here as well, I just multiplied that by 3 and got that. And this is pi and 2 pi. So just putting it into the calculator using pi is 3.14. So let's kind of look at some examples here. If I asked you to sketch 13 pi over 8, well, is 13 pi over 8 on the unit circle? Well, we don't know yet. We haven't looked at it, but I can still ask you to graph it. So what I'm going to do is I'm going to put my quadrantals in terms of pi over 8. So I'm going to start here with 0. So if pi over 2 with the denominator of 8 would be 4 pi over 8. Pi with the denominator of 8 would be 8 pi over 8. Down here, 3 pi over 2 in terms of pi over 8 would be 12 pi over 8. And then over here would be 16 pi over 8. So I put my quadrantal angles in terms of a denominator of over 8, or denominator of 8. So where would 13 pi over 8 be? Well, I'm going to say maybe somewhere over here. Because again, I'm going from this initial side and going in that counterclockwise rotation. So that's where, 13 pi over 8 is. You can also think about 13 pi over 8 being 1 and 5 pi over 8. Putting it into a mixed fraction where you're dividing 13 by 8. And, okay, how many 8s are in 13? 1. With how many left over? Oh, 5. So 1 and 5/8. So that would say that you're going half the circle, pi, and 5/8, which is more than a half. Well, again, we talked about that I can ask you to graph pretty much any number because radians are just numbers. So you just have to change your perspective of the quadrantals. So since we're talking about negative, I'm going to kind of put this axes in terms of negative numbers. So I'm going to start here at 0. Down here is going to be negative 1.57. This is going to be negative 3.14. And this is going to be negative 4.71. And you could say that this is negative 6.28. We don't need this. And this is all optional. I'm just doing this for my notes so that y'all can kind of understand where exactly is negative 4.15 in radians. Well, definitely going to be more than negative 3.14 and less than negative 4.71. So I'm just going to approximate it to be somewhere here. And again, since I'm going in a negative rotation, I'm going to go counterclockwise or clockwise and draw my kind of arrow that way. Okay, so again, I can ask you to graph any number. I can ask you to graph any degrees as well. But in today's notes, we're talking about radians. Now, anything that we did with degrees, we can actually do with radians. So something that we did with degrees was find a coterminal angle. That means we were kind of adding or subtracting 360, going in circles until we got to an answer that we wanted. Well, if we're given negative pi over 15, I'm going to add a circle to that so that I can get a positive and negative coterminal angle. Well, a full circle in radians isn't 360 it's 2 pi. So you have to kind of, change your thinking around. It's still, we're adding a circle, but our circle now is 2 pi. So what I need to do is add negative pi over 15 and 2 pi. Well, in order to do that, I need to get a common denominator. So I'm going to multiply the top and the bottom of 2 pi, and remember the bottom of any fraction is always 1, by 15. So this is going to be 30 pi over 15. And when you add fractions, you just add the tops, and you leave the bottoms alone, which is the reason why we have to get a common denominator. So there's my positive coterminal angle. Well, the same thing happens for negative. I'm going to have to subtract a circle, but my circle is, in radians, is 2 pi. So I need to get that to be a common denominator. I subtract the tops and get negative 3 pi over 15. Hopefully, some of y'all kind of remember from the first quiz that we did that, if your angle's negative, then your answer's negative, and you need to put that in your answer. I don't just say, oh, this is a negative coterminal angle and say it's 31 pi over 15. That doesn't work. It needs to actually have a negative sign. Now, we've talked about this already. So I talked about a full circle being 2 pi. So a full circle in degrees is 360, and they're still illustrating the same circle. So our conversion is really 2 pi equals 360 degrees. But like every fraction, it should be reduced. So let's make this number smaller. Pi is essentially just 180 degrees. So if I were to divide pi by 180, or 180 divided by pi, that's essentially going to be 1. Okay, 180 degrees divided by pi is essentially 1. So, if I were to put this into the calculator, well, what is 180 degrees divided by pi? Well, it's actually 57.3 degrees, which is how I got that 1 radian. So let's talk about converting. A lot of y'all have done a lot of converting, hopefully in science. It's called dimensional analysis, and that's how I like to teach it. Some of y'all do railroad tracks and all that stuff, but it's not going to be too complicated of a conversion. So I need to multiply this by 1. Well, my 1 again is going to either be pi over 80, or 180 degrees, or 180 degrees divided by pi, depending on what I need. But they're both essentially 1. All right, well, my dimensional analysis tells me that I need to cancel out degrees. Well, if I need to cancel out degrees, that means it needs to be on the opposite side of that fraction bar. Well, again, I'm multiplying by 1, and 1 in converting radians to degrees is pi over 180, or 180 over pi. So I'm going to multiply this by pi over 180. So what happens here? Well, the units disappear because degrees divided by degrees is 1. Well, both the top and the bottom are divisible by 10, so I'm going to take off those zeros. So this pretty much multiplies to 54 pi over 18. Can I leave my answer like that? No, it's not reduced. You need to fully reduce any fraction that you have. You can think that these are both divisible by 9. That's fine. You can see that they're both even, so you can divide it by 2. But really, they're both divisible by 18, and 54 divided by 18 is 3 pi. Make sure you always reduce your fractions. That's something that's implied in any math problem that you do. Well, what about B? Negative 23 degrees. How do I convert that? Well, again, what we're going to do is just multiply it by pi over 180 degrees, because the degrees here cancel off. You are doing dimensional analysis. So what I'm going to do here is just multiply straight across. So negative 23 pi over 180. And that's it. I could have left it like that if it asked you to just put it in, or if it just asked you to convert it and didn't say anything about decimal approximation, then that would be your answer. But in my directions, it's asking you to do that. So what we do is we type that into the calculator, and you end up getting negative 0.401 in the calculator. So again, I'm just typing in negative 23 times pi and dividing it by 180 and getting a decimal. Well, what about number 4? Now, how do I rewrite something that's in radians and put it into degrees? Well, again, I'm going to do my dimensional analysis. So 34 pi over 15, and I'm going to multiply it by 1. Again, my 1s look different depending on what I want. I can do pi over 180, which I did here, or I can multiply by 180 over pi, which I'm going to do here because I need to cancel out this pi. So I'm going to put pi down here on the bottom, and again, what it's equivalent to in degrees is 180 degrees. So what happens here is that our pi's cancel off, and you do some reducing, and you end up getting that this is 408 degrees. Again, in the notes, I don't need to teach you how to reduce fractions. That's something that you should, know how to do and definitely need to practice. So, definitely that. So sometimes you're not going to be given a calculator. Sometimes you are. So if you do have a calculator, you could have just multiplied 34 times 180 and divided by 15. Got 408. So here's a decimal approximation of 1. Well, you could always do this. You could always multiply and do dimensional analysis and multiply by 180 over pi. Or, again, pi is 180 degrees. So something you could essentially do is just substitute pi with 180 degrees. So if you put this into the calculator and round to 3 decimal places, you actually get 334 degrees, or 334.286 degrees. And again, depending on the question, if it's, putting it into the calculator, if you have a calculator, if you're even allowed one, just make sure that you're following directions. All right, just like how we did with lesson A, we learned about all these exact values on the unit circle in degrees. So I didn't want to bore you and have you watch me fill out all of the exact values in ordered pairs on this. So I just did that off camera and letting you see it now. So what we're trying to get you to understand is how to put the radian values on this unit circle. So we already kind of talked about some of them, the quadrantals, where this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and you can say that this is also 2 pi, depending on the directions if you do include 0 or 2 pi. Now what about these other angles? Well, this first angle here that we usually talk about is 30 degrees. So let's do a little bit of converting. What is 30 degrees in radians? Well, I need to multiply by pi over 180. Well, 30 over 180 reduces to pi over 6. So that means this angle right here in radians is going to be pi over 6. That means any angle is going to be, or any 30 degree angle is going to be something over 6. So what I'm going to do pretty much here, just kind of for note sakes, is for each one of these, I'm going to put over 6. There's something else that goes in front of them, but I want you to understand that any 30 degree angle will always be pi over 6. 60 degrees, if we convert that, we end up getting pi over 3. So each of my 60 degree family or reference angles are always going to be pi over 3. So I'm going to put over here something pi over 3, something pi over 3, and something pi over 3. The reason I say this is because I always keep asking students questions about, if it's this certain exact value, give it to me in radians, and I always get different denominators for student answers, and it's not supposed to be. If I'm asking you for a radian value of an exact value on a unit circle, both fractions should be the exact same denominator. It cannot be 30 degrees and 60 degrees. It can't be pi over 6 and pi over 3. It's going to be completely different. What about these other ones, this 45 degree one? Well, if I convert that, you end up getting pi over 4. So this is going to be pi over 4, and every single 45 degree angle on our unit circle is going to be pi over 4. Okay. Now, how do I get this pi over 4? Well, you can convert it at any time. Like if you want to convert 150 degrees to radians, you can do all the conversion, or it's going to be easier to remember. So for note's sake, the way that I try to get you out to kind of get the idea of how we're going through the unit circle is I like to go through each 30-degree angle. So 30 degrees in radians is pi over 6. My next 30 degrees would be 60 degrees, so I could think about that as 2 pi over 6. But again, like every fraction we reduce it, is pi over 3. Where's my next 30-degree angle? Well, from 60 would be 90. So this angle here would be 3 pi over 6, which reduces to pi over 2. This next 30-degree angle, because from 90 to 120 is 30 degrees, is 4 pi over 6, which reduces to 2 pi over 3, which is going to be that angle there. My next 30-degree angle is not this 135 here, but it's actually this 150. This is going to be 5 pi over 6, which doesn't reduce, so I'm just going to leave it as 5 pi over 6. My next 30 degrees from 150 to 180 is 30 degrees, so this is another pi over 6, which is 6 pi over 6. Then I can keep doing that, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Well, 7 pi over 6 doesn't reduce, so that's going to stay there. 8 pi over 6 reduces to 4 pi over 3. 10 pi over 6 reduces to 5 pi over 3. And 11 pi over 6 just stays 11 pi over 6. It doesn't reduce. And you can kind of say, oh, well, this is 12 pi over 6, which, yes, is 2 pi. You can kind of do the same thing with pi over 4. So you're going to go by 45-degree increments. So this is 1 pi over 4. This is 2 pi over 4, which reduces. This is 3 pi over 4, which I'm just going to write here. Sorry. This is 4 pi over 4. This is 5 pi over 4, which doesn't reduce. You can think about this being 6 pi over 4, which reduces to 3 halves. And then over here is 7 pi over 4. So look at that pattern. If we go through the whole unit circle by pi over 6's, then we can figure out what each of the 30-degree increments ones are. And we can do the same thing with 45. And then you can kind of think about 2 pi being 8 pi over 4 if you wanted to continue the pattern. You can also do by 60-degree increments. So if you're going from 60 to 120, that's pi over 3 and then 2 pi over 3. And then the next 60 would be 180, which is 3 pi over 3. Again, figuring out a way to associate those together. What's really helpful is just knowing that 30 degrees is always pi over 6. So if you have a denominator of 6, it's in the 30-degree family. If you have pi over 3, it's a 60-degree family, so that's helpful. And then, of course, if it ends in a 5 or over 4, those are both 45 degrees. So pretty much what we're doing is we're dealing with the same unit circle, just putting a different perspective on it of radians or degrees, and they're going to be all essentially the same questions. All right, so how can I use the unit circle in radians in order to find two angles for a specific exact value? So most cases in this class, when you see the theta symbol, we're talking about degrees. If we're talking about x, it's usually radians, and I kind of wrote that here in my notes. But sometimes you just kind of need to pay attention to directions, and this is something that I need to add to the packet. But most directions on a quiz or test will tell you that the variable is somewhere between two angles. In this case, we're going to talk about all the angles about 0, which could be equal to. So all the angles are going to be between 0 or 2 pi, including 0, but not including 2 pi. So since you kind of have a unit circle on the top half of your page, you could probably use a unit circle to figure out these angles, but what I would strongly suggest to do is to make sure you have these memorized. So sine, what two angles, and it could be 0 angles, it could be 1 angle, but how many angles or which angles give us that sine is the exact value of root 3 over 2. Using your unit circle, you could go about seeing, okay, well, sine is a y value. Where is y root 3 over 2? Well, here and here. So our angles would be pi over 3 and 2 pi over 3. So something that a lot of students do with these on quizzes and tests are give me two different denominators. There is no way on the unit circle in which you can have the same exact value for sine or cosine or tangent or any of the six trig functions and be at something pi over 3, pi over 4, and or pi over 6. Like, it can't have different denominators. What about where tangent of x is 1? Well, if you think about this, okay, well, tangent is y over x. If y over x is 1, that means y and x are the exact same thing. Well, the only time that x and y are the same thing is at pi over 4, or 45 degrees. So each of my denominators will be pi over 4. But the thing is that they both can't be the same answer, so how do I figure out the other one? Well, if it's positive 1, they're both positive, which is at pi over 4, or they're both negative, which is at 3 pi over 4. Or sorry, 5 pi over 4. Just like in class, I always make mistakes. What about cosine is negative a half? Well, if you think about the unit circle, cosine is negative a half at a short distance to the left, which means that those are going to be your pi over 3s. So it's the point that's really high up or really low on the unit circle. So pi over 3. And again, both of these fractions should be the exact same denominator. But cosine is negative. Cosine is negative when it's going to the left, so that's quadrant 2, 2 pi over 3, or quadrant 3 at 4 pi over 3. Again, this is probably the first time we're doing this, and again, you can look at the unit circle since it's here, but you're not always going to have a unit circle. You don't have time to draw out a full unit circle every single time. Where is sine root 2 over 2? Well, root 2 over 2 should think of 45 degrees or pi over 4. So again, if they're going to be two answers, they're both going to be the same denominator. Well, sine being positive root 2 over 2 means that it's going upwards, which means sine is positive in quadrant 1, which is pi over 4, and quadrant 2, which is 3 pi over 4, which is actually 3 pi over 4. It's not going to change. Where is cosine negative 1? Well, you can look at the unit circle and look to find where on our unit circle do we have an x value that's at negative 1. Well, the only place that is at pi, which again, could be one answer. There's no second angle that gives us where cosine is negative 1. Because remember, cosine is the x coordinate of the point on our unit circle. What about this one? Cosine of x is negative root 3 over 2. Well, cosine is negative, so it's going to go to the left. So it's going to be quadrants 2 and 3. It's going to be root 3 over 2, which means that it's going a further distance away. So it's like the leftmost point of the unit circle that's not at pi. So that's going to be pi over 6. But pi over 6 in quadrant 2 is 5 pi over 6 in quadrant 3. It's 7 pi over 6 because, again, cosine's negative, so it's going to the left. We're looking for the x-coordinate of the ordered pair on the unit circle. That's negative root 3 over 2. What about sine being negative root 2 over 2? Well, to be honest, anytime you're dealing with sine or cosine, or maybe even secant or cosecant, it has a root 2, it's always going to be pi over 4. But we're talking about negative root 2 over 2, which means that the y-coordinate of the point is going down. So that's quadrant 3 and 4, which pi over 4 in quadrant 3 is 5 pi over 4, and in quadrant 4 is 7 pi over 4. What ordered pair has an x-coordinate that's 1? Well, the only place on the unit circle that happens is at 0, and there's no other place. You could put 2 pi if the directions tell you to include it. In this, the directions are telling us not to include 2 pi, so you don't include 2 pi. What about sine of x is negative a half? Well, that's going to go down, so quadrant 3 and 4. It's going to go down a short distance, so it's going to be 7 pi over 6, which is in quadrant 3, and 11 pi over 6, which is in quadrant 4. What about tangent is root 3? Well, this might be something that you want to commit to memory. Tangent is root 3 at pi over 3. That's just something that'd be helpful. If it was tangent is root 3 over 3, that would be pi over 6. So try to figure out a benchmark for you to remember those tangents. But tangent is positive in where they're both positive, which in quadrant 1, or both negative, which is in quadrant 3. So what's pi over 3 in quadrant 3? 4 pi over 3. Where is tangent undefined? Well, for it something to be undefined, it has to be divided by 0. Well, that means that since it's tangent, we're talking about y over x. We're talking about where on the unit circle do we have an x-coordinate that's at 0? Well, the only 2 points is when y is 1 or -1. And those points are at pi over 2 and 3 pi over 2. Given a point, -3/5 comma y is on a unit circle, very important that it's on a unit circle, find the 6 trig functions if p is in quadrant 3. So, on my scratch paper here, I'm going to say that point P is right here on my unit circle. Well, if it's on the unit circle, what's the radius? 1. And it's telling me that I went -3/5 in this direction. Okay, so I know 2 of the side lengths. I could do Pythagorean theorem or know my triples. What could I do to get rid of this fraction? Well, I can get a similar triangle and multiply it all by 5. So if I multiply this by 5, I get -3. If I multiply this by 5, you get 5. Well, then that means that this will have to be 4. But remember that if we're going down, we're going -4. So really, we can find out that this side length here is -4/5 without having to do Pythagorean theorem. That's how we can use our triples. 3, 4, 5, 3/5, 4/5, 1/5 is all the same, or 1 would all be a similar triangle. Okay, not 1/5. It's -3/5, -4/5, and 1. The hypotenuse would have to be 1 for that to work out. 1/5 is smaller than the other 2, and that can't work. So, a little slip of the mouth there. So again, our angle, our reference angle for all of these triangles is always here at the origin. So if I'm looking for sine of this, well, you can kind of get the idea that sine is always our y value. What would the y value of this point be if we had -3/5 as x? Well, -4/5. And again, knowing that it's negative is very important. So really all I need is the y value of this point, which is -4/5. We already gave you the answer for cosine because that's just the x value of that point on a unit circle. It is very important to understand that this was on a unit circle, so the hypotenuse has to be 1. And then what happens if I divide this y by this x? Well, -4/5 divided by -3/5 would be 4/3. Oh man, how do I get these other 3 trig functions? Well, they're reciprocals of this one. So you just do -5/4, -5/3, and +3/4. And again, when you're typing this into Blend, that negative sign should always be first. We shouldn't be doing 5 over -4. We can't be typing in every different possibility of y'all typing things into Blend. So make sure that y'all know the appropriate way of reducing your fractions and putting negative signs in the front. All right, let's look at this last question here. You're going to be able to recognize when radians are on our unit circle that we can find exact values on and when you're not. So like pi over 6, we know that pi over 6 is part of that 30-degree family. So we know that these 2 values, pi over 6 and pi over 2, since they're on the unit circle, that denominator is, we can do that. If I gave you 19 pi over 5, that is not something we can find on our unit circle because we don't have that family of pi over 5. So you should recognize when we do and do not have radians that we can find exact values on the unit circle. Now, if you're thinking about 19 pi over 6, it's a little big. If you're thinking about what 2 pi is in terms of pi over 6, that's only 12 pi over 6. So this is definitely bigger than 2 pi. So let's find a coterminal angle, preferably a positive one. So I'm going to take 19 pi over 6 and subtract 2 pi from it. Well, subtracting 2 pi from this would be subtracting 12 pi over 6, which we end up getting 7 pi over 6. So all of these questions are the exact same thing as finding out what 7 pi over 6 is. So sine of 19 pi over 6 or 7 pi over 6 is going to be the exact same answer, -1/2. Cosine of 19 pi over 6 or cosine of 7 pi over 6 is going to be the exact same answer as -√3/2. Tangent is the y over the x. So if you think about it this way, where you're dividing negative 1/2 by negative root 3 over 2, what's going to become positive, and you're going to have 1 over root 3, which we can't have, so it's root 3 over 3. So just something to maybe commit to memory is that tangent of 30 or tangent of pi over 6 is always just root 3 over 3. Well, pi over 2 is one of our quadrantals. It's either 1 pi over 2 or 3 pi over 2. So let's figure out how to do that. So let's find a coterminal angle for that. So I'm going to have to subtract 2 pi from this, and that really looks like 4 pi. So if I subtract 4 pi over 2 from 11 pi over 2, we get 7 pi over 2, which is still not one of my quadrantals. So if I do that again, I get 3 pi over 2, which is on my unit circle. I can recognize 3 pi over 2 because it's right here. 7 pi over 2 or 11 pi over 2 might not look like it, but again, I'm doing a coterminal angle. I keep subtracting circles from it. So at 3 pi over 2, my y value is -1, my x is 0, and tangent is y over x, so you end up getting undefined. If you have any questions, make sure that you ask during tutorials or ask during class. See y'all next time.